We're going to continue learning about proportional relationships, and this lesson is mainly focused on graphs and equations and how we can use the graphs and the equations, and you'll see some tables as well, to determine proportional relationships, the constant of proportionality, unit rate. So let's check it out. A candy company sells peanut brittle and almond bark. The information for both types of candy is shown. So we have a graph for the peanut brittle and we have a table for the almond bark. Determine how much more one candy costs per ounce than the other candy. Now you see that, right? Per ounce. Per ounce means that we're finding the unit rate or the constant of proportionality. So if you remember when we talked about that, the unit rate will have an x value, right? Because we're looking at points. It'll have an x value of 1. So that makes it easy, right? If we have a point that has an x value of 1. So let's see what we've got. In the graph, 1 would be right here. So if I follow that up to the line, it's kind of hard to see what that's going to equal, right? Let's look at a different point, maybe one that we can see. Oh, here we go. So I can see this point is right on the intersection of 10 and 10. So this point is 10, 10, right? My x value is 10 ounces. My y value is $10. There's not another, oh, wait, here we go. Here's another point. I was going to say there's not another one, but there's a good point too. So that point is, if I follow it down, 20, and then if I follow it across, also 20. So this point is 20, 20. Okay, so if you remember when we found the unit rate, that's the same thing as the constant of proportionality. And to find that, we did y divided by x. So regardless of which point I choose, I'll just choose 10, 10. I'm going to do 10 divided by 10, and I get 1. So since I am doing money, right, divided by ounces, this means that this is $1 per 1 ounce, right? Or $1 per ounce, which is what we were asked to find. All right, let's look at the table. For the table, we're also going to do y divided by x. Doesn't matter which point we pick, so I'm going to go with the one that's easiest to divide in my head because I can divide this pretty easily. So my y value, remember, is cost, right, is money, and my x value is ounces. So I'm going to do y, which is 16, divided by 10. And when we divide by 10, we just move the decimal point back 1. So that's 1.6. Now remember, this is money, right? So that's going to be $1.60 for 1 ounce. So how much more does one candy cost per ounce than the other? Well, this one costs $1.60 per ounce. This one costs $1 per ounce. So the almond bark costs 60 cents more per ounce. All right, let's take a look at another one. The time it takes to read 20 pages of a book can be represented with this equation, where y is the total time in minutes, and x is the number of pages read. Determine how long it will take to read a book that has 424 pages. So I'm going to write my equation. I'm going to write y equals 12.4 over 20 times x. And then I'm also going to write in what each of these represents, right? So y is my minutes, and X is my pages, right? And I just got that from the parts that I underlined in the problem, right, where it tells me what Y and X are. So now, if I want to know how long it's going to take to read 424 pages, I'm going to have to take this 424 and put it in for the number of pages. So it's going to look like this. Y equals 12.4 over 20 times 424, right? Because before it said times X. Remember, that fraction right next to the X means multiply. So instead of writing 12.4 over 20 times X, I'm going to write 12.4 over 20 times 424, because that's what they're telling me to use for X, because that's pages, right? Okay, so now I'm going to use my calculator. And the way that I'm going to do this is I'm going to think about this as being over 1. So I'm going to multiply my top numbers, 12.4 times 424, it's a big number, is 5,257.6. And on the bottom I've got 20. And when I divided by 20, I get 262.8, hold on, 8. All right, 262.88. That is minutes. So that's how long it will take, 262.88 minutes. Now, usually it'll tell you to round to the nearest minute because we don't usually measure in like hundredths of a minute. So if we round this to the nearest minute, it would be 263 minutes. If it doesn't tell you to round, then you just leave it like that. All right, let's take a look at the next one. As 3 students are participating in a walkathon, the data for each student is shown. Student A has this equation where the amount of money raised is Y, so Y is money and X is miles. Okay. Student B raised $45 for walking 3 miles, and then student C, we have 2 different points that we can use. 5 miles raised $75 and 7 miles raised $105. These are all proportional relationships, so that's important to note. It should have said that somewhere in the problem. So let's look at student A. We know that when we see an equation like this, right, which is what this looks like, that the number that's right here is our constant of proportionality, also called our unit rate, right? So let's find the unit rate. Let's find how much money each student makes per mile, because then we can figure out which student raised the least amount of money, right? After 6 miles. Okay. So we're going to use this equation. We know that this unit rate from the equation, the unit rate or the constant of proportionality is 15. That means that the student raised $15, right, because that's Y, per mile. Because Y divided by X, which is money divided by miles, is 15. So that's $15 for 1 mile, right? So that's student A. For student B, we're going to do the Y, which is, remember, the money, divided by X, which is the miles. So for student B, we have 45 divided by 3. Again, that's Y divided by X, money divided by miles, which is also 15. So $15 for 1 mile. All right, let's look at student C. For student C, I can pick either point. I'm going to pick the smaller one. So for student C, the constant of proportionality, again, is going to be money raised divided by miles, because it's y divided by x. And I get, I believe that's 15 again. Let's see. Yes, that is. So then that's also $15 per 1 mile, right? Or $15 per mile. So since they all have the same unit rate, they would all raise the same amount of money after 6 miles. How much would that be? Well, if we found that they raise $15 for 1 mile, then to figure out how much they raise for 6 miles, we would just do 15 times 6, right? $15 for every mile, and we've got 6 miles, so 15 times 6 would be $90. And they would all raise that amount because they all have the same unit rate. All right, moving right along. The number of ounces of chocolate chips per batch of cookies can be represented with this equation, where y represents, where y represents the ounces of chocolate chips and x represents batches of cookies. Determine how many batches of cookies can be made using 28 ounces of chocolate chips. Okay, so I'm going to do the same thing I did when they gave us an equation the last time, and I'm going to write the equation down here. Y equals 8x, and I'm also going to write what each variable is. So y, it says, is the ounces of chocolate chips. So I'm going to put ounces, and then x is the batches of cookies. So I'm going to put batches. Okay, so now it says determine how many batches of cookies can be made using 28 ounces of chocolate chips. So what we have to figure out is, where do I put the 28? Do I put the 28 in place of the y, or do I put the 28 in place of the x? And I probably should have paused to ask you that question last time. So think about it. Where should that 28 go? It's 28 ounces of chocolate chips. So, should that go in the y spot or the x spot? Well, y represents ounces of chocolate chips. So if I'm told that it's 28 ounces of chocolate chips, then that's where the 28 should go. It should go in the y spot. And now I write the rest of my equation, and it's asking me how many batches. So I'm solving for x. This is a one-step equation. We know how to do this, right? The x is being multiplied by 8. So to undo that, we divide by 8. And again, I'm going to do that on my calculator. I'm just going to simplify. So I'm going to divide both of them by 4. This would become a 7, and then this would become a 2, and 7 divided by 2 is 3.5. So I would get that x is equal to 7 over 2, which is 3.5. So I can make 3.5 batches of cookies using that 28 ounces of chocolate chips. All right, one more. You're completing a math assessment. The number of questions you complete and the time it takes you to complete them have a proportional relationship, as shown in the table. How much time does it take to complete 7 questions? Okay, so if you remember, when we talk about time, and I know there was another example in here where time was the dependent variable, which is strange that they set it up like that. Time is almost always the independent variable, right? So, but it looks like in this question, usually they put x on top and y on the bottom. So we could actually solve this either way. we could make time x, which I think makes more sense, or we can make time y. So, time is usually independent, so I'm going to go with making this x and this y. Okay, so let's write our equation. So to write the equation, we need to know k, right? So k is y over x, and I only have one x and y pair that I can use because the other one, I don't know one of the numbers, right? So my y value is 4 and my x value is 6. Okay, I'm going to reduce that. That can be reduced to 2/3. So my k, or my constant of proportionality, is 2/3. So now I'm going to use my equation y equals kx to write y equals 2/3 x. All right, now, just like the other ones, I'm going to label. My y value is questions, and my x value is time, or I could write minutes. So now, when it's asking me how much time does it take to complete 7 questions, I just have to figure out, where does the 7 go? Does it go in place of the y or in place of the x? Think about it. Does it go in place of the y or in place of the x? Well, it's 7 questions, right? And questions is y. So it's going to go in place of the y. So I'm going to have 7 equals 2/3 x. Now, let's see if you remember how to solve this one. Again, we have to divide, right? Because the x is being multiplied by 2/3. But when we divide by a fraction, think about how we do that. How do we divide by 2/3? Remember, how do we divide by a fraction? We multiply by the reciprocal. Right. Keep, change, flip. I can hear some of you saying it right now. So I'm going to multiply by 3/2 on the right, and I'm going to multiply by 3/2 here as well. Now notice I put the 7/1. It's just because I like them both to be fractions if they're going to be fractions. All right, so now that cancels out, right? That just gives me 6/6, which is 1. And then I do 3 times 7 on top, 2 times 1 on the bottom. That's going to be 21/2, which is 21 divided by 2 is 10 and a half. So it will take me 10 and a half minutes to complete 7 questions. All right, so in this lesson, you're basically finding that constant of proportionality or a unit rate, whatever you want to call it, using that to write your equation, and then using the equation to like plug one of them in and solve for the other. And as always, any questions, take a picture, send it to me, let me know so I can help.